So today we are going to talk about a flexible price monetary model with persistent output drop. So I tend to use a real exam question for this topic because the derivation is a very good example of what should be expected to do in every problem. So first we have a definition for an object K, which is this. So this is a parameter specified by the question. And what we are trying to get is an equation for S, which is the nominal exchange rate. That is defined as the domestic price for foreign currency. So for the derivation, we start by using purchasing power parity, that is S is the difference in domestic and foreign prices, and then we use the LM equation, which is the relationship between money demand and money supply. So money demand is a function of Y and I, and that should be equal to the money supply, which is M over P. And here all the objects are expressed in terms of logs and differences. So we substitute that in, and then we note that this term is K, and this term by the UIP equation, which says that the domestic nominal interest rate should be equal to the foreign interest rate plus expected depreciation. And then this is a function of S, and by rearranging we can see that this is what we are trying to get. And by repeated substitution of st plus 1 into the future, we are going to get this term in the end, and also the no bubble condition. When that is applied, we are going to get this term only. So notice a few things here. So this is gonna be taken out, and notice the summation term goes from t to infinity, and that should also be the case. That should not be the case when there is a finite t periods, when the summation should go from t to capital T instead. So initially we have assumed that S is equal to 0, and then expected K is 0, and those terms are exogenous and their expectations are equal. So now we have a decrease in output of 10% that happens from T onwards, and then we have a further decrease in period T plus 1. So that is just given. So by using our equation, we can see what happens to S. So notice that we only have one term here because the first decrease will happen for one term, and then from period T plus 1 onwards, the reduction in output is going to be permanent. So the change in K is also going to be permanent. So notice that here we can see the difference in K is the inverse of the difference in Y times a constant. So be sure to include this constant, and this is subbing it in. This is using the summation formula, and also taking out the first term 1/5 to ensure we can use the summation equation. Be sure to include the constant that I've mentioned, and then this is the depreciation we are going to get in period T, and then from period T+1 onwards, we will ignore everything and only get this term left. So this is what we get in the period T+1. So starting from T equals 0, the expected output drop leads to a depreciation by 4.2% in period T and appreciation by 3.2 in period T+1. No further change in exchange rate, and that's that. So the interpretation is that the expectation of lower future output reduces the real money demand, so people use excess real money balance to purchase more goods, which increases price and thus reduces the demand for the currency. People expect immediate depreciation, and as bonds are less attractive, the depreciation will happen now, which is consistent with the UIP result. That is, when people are expecting a depreciation, the depreciation should actually happen immediately.